Hi, my name is Nikita Ghosh. Today I am going to talk to you about wedge friction in engineering mechanics. Now, in this slide, we are going to talk about wedge. A wedge is a triangular shaped tool with an inclined surface. It is used to convert a force applied in one direction into a force acting in a perpendicular direction. Now, what is wedge friction? Wedge friction refers to the resistance encountered when a wedge-shaped object or tool is pushed or pulled between two surfaces. It is a type of mechanical friction that occurs due to the interaction between the wedge and the surfaces it is in contact with. The frictional force between the surfaces in contact plays a significant role in determining the effort required to move the wedge and the object. Factors affecting wedge friction. Surface factors. Smooth surfaces reduce friction while rough surfaces increase it. In case of lubrication, adding lubrication reduces the coefficient of friction, making it easier to move the wedge. In case of wedge factors, wedge angle is the angle of inclination of the wedge sloping surface. A smaller wedge angle requires less force to lift or separate objects, but increases friction due to greater contact area. Whereas a larger wedge angle reduces friction, but requires more applied force to overcome the incline. Next comes the environmental factors. Temperature. High temperatures can alter material properties, reducing or increasing friction. Vibration. Vibrations can reduce static friction, making it easier to initiate motion. Wear and tear. Over time, surfaces may wear down, altering friction coefficients. Force factors. Normal force is the perpendicular force exerted by the surfaces in contact with the wedge. Frictional force, that is F equal to mu n, is directly proportional to the normal force. A heavier load increases the normal force, thereby increasing friction. A lighter load decreases n, that is normal force, which reduces friction. Next comes is the material factors. Metals such as steel typically have lower friction coefficients. Non-metals, example wood, may have higher coefficients due to surface roughness. Surface finish. The smooth surfaces reduces friction while rough surfaces increases it. Next, interactions. The interactions of the area of contact between the wedge and the surfaces. The effect is that larger contact areas increase friction due to greater interaction between surfaces. Smaller contact areas reduce friction but may increase wear and deformation. Types of wedge friction. Static wedge friction. This occurs when the wedge is stationary and friction prevents it from moving. The characteristics of the static wedge friction are as follows. The applied force P is less than the frictional resistance. Frictional force equals the applied force up to the maximum limit, that is F max equal to mu into N, where N is the normal force. It is important in applications where stability is required, such as wedges used for holding objects in place. Next comes kinetic wedge friction. This occurs when the wedge is in motion and friction opposes the relative motion. The frictional force is constant and typically lower than static friction. This kind of friction is found in systems where the wedge is repeatedly moved, such as in cutting or splitting tools, governed by the kinetic coefficient of friction mu into K, where K is the kinetic friction. Next is the rolling wedge friction. Rolling wedge friction refers to the frictional force encountered in systems where a wedge incorporates rolling motion instead of purely sliding. Rolling wedges are often used to reduce friction in applications where a wedge needs to move efficiently while still applying force. Calculating wedge friction. The formula is F equal to mu into N. N is the normal force, F is the frictional force, and mu is the friction coefficient. Here, the calculation of wedge friction involves analyzing the forces acting on the wedges and the object it is used to lift or separate. This calculation typically includes the applied force, the normal forces, and the frictional forces. Our next slide is the applications of wedge friction. Constructing and engineering. Foundation piles. Wedges are used to secure foundation piles in the ground. Retaining walls. Wedge-shaped blocks can be used to construct retaining walls. It is also used in our everyday life. Knives. The blade of a knife is essentially a wedge used to cut through food. Zippers. The interlocking teeth of a zipper function like teeny wedges. Next comes is the manufacturing and assembly. Wedge friction is widely used in manufacturing and assembly processes because it enables precise control of force and motion, provides stability, and ensures secure connections. Clamping and fixing components. Wedge friction is used in clamping mechanisms such as machine vices and jigs. For example, a wedge-shaped component is driven into place to create a high clamping force with minimal effort. Friction between the wedge and the surfaces prevents slippage, ensuring components are held securely during machining or assembly. Next is the transportation. Wedge friction is utilized in various aspects of transportation to enhance safety, stability, and efficiency. For example, it is used in braking systems. Wedge friction is used in certain braking systems such as mechanical brakes on trains or vehicles. The way it works is that a wedge-shaped mechanism applies pressure to brake pads or shoes, pressing them against the wheel or discs. The amplified friction slows or stops the vehicle efficiently. Example, older rail cars used wedge brakes to apply force on wheels, and some heavy vehicles use wedge actuated drum brakes. Next is aerospace. In aerospace, wedge friction is critical in various systems for enhancing safety, efficiency, and stability under extreme operating conditions. In landing gear systems, wedge mechanisms are used in the locking and braking systems of landing gear. The way it works is that wedges lock landing gear in place during deployment, ensuring structural stability during landing and taxiing. In braking systems, wedge actuated brakes amplify the frictional force on wheels, for efficient stopping during landing. Medical and healthcare. Wedge friction plays a crucial role in the medical and healthcare industries by enabling precise controls, stability, and safety in various applications. It is used in surgical instruments. Wedges are integrated into clamps, forceps, and other surgical tools. The way it works, wedge friction provides secure grip and controlled clamping force, ensuring precision during surgical procedures without damaging tissues. The next is consumer products. Wedge friction is extensively used in consumer products to enhance functionality, stability, and ease of use. The one use is in case of furniture, adjustable chairs, tables, and sleeping units. Wedge mechanisms are used for height or angle adjustments. Friction ensures the components lock securely in place, providing stability during use. There are many more other products such as door steps and anti-slip devices, hand tools, kitchen gadgets, etc. Wedge friction plays a crucial role in robotics and automation, where precision, stability, and efficiency are essential, and effector grippers. Robotic arms with grippers for handling objects is used as an application of this friction. Wedge-shaped components in gripper mechanisms amplify clamping force and create high friction, ensuring secure and precise handling of objects of varying sizes and shapes. It is also used in linear actuators, robotic joints and hinges, assembly and fastening robots, climbing robots, robotic stabilization, and many more. Here is one numerical on wedge friction. A block of weight 20 kN is to be raised by means of a wedge. Find the value of P for impending motion of block A. Angle of friction for all the contact surfaces given is 15 degree. Now, first we need to find the free body diagram of wedge. Here, we know P is the normal force already acting given. The reacting force will always act perpendicular to the surface of contact. N1 and N2, here N2 and here N1, both are the reacting force acting on the surface. F2 is the frictional force because here frictional force F2 and here frictional force is F1. Since the force is acting in this direction, the friction force will be opposite to that direction. R2 and R1 is the resultant of N1 and F2. N2 and F2, R2 is the resultant, and here R1 is the resultant of N1 and F1. And phi already given 15 degree. This one is complete. Next, free body diagram of block A. Here N3, same, is the reacting force perpendicular to the surface. F3 is the frictional force and R3 is the resultant of the normal force and the frictional force. 20 kN force already given, and here also R2 is the reacting force, N2 is the R2 is the resultant force, N2 is the reacting force, and F2 is the frictional force acting on the block. With the help of Lemmy's theorem, we can find the force and the opposite angle between the other two forces is the Lemmy's theorem. F2 by sine of 75 degree, F2 by sine of 75 degree equal to 20 kN by sine of 140 degree, and which is equal to R3 by sine of 145 degree. Next we calculate R2 by sine 75 degree equal to 20 by sine 140 degree. R2, we find this with the help of calculator and we got the actual result 30.054 Newton. Again, we need to find the actual P. R1 by sine of 125 degree with the help of Lami's theorem. The force acting is always equal to the angle between the other two forces. R1 by sine of 125 degree. This one is R1. Oh, I forgot to write R1 by sine of 125 degree equal to R2 by sine of 105 degree equal to P by sine of 130 degree. R2 by sine of 105 degree equal to P of sine 130 degree. From here, after calculating, we find the value of P equal to 23.834 kilonewton. Another one example. Determine the force P as shown in figure. To start the movement of wedge, the angle of the friction at all the contact surfaces is 15 degree. Phi is already given 15 degree. First, we need to find the free body diagram of wedge. This one is wedge, this one is block. In this case, P is already given force, contact force N2, and here F1 is the force acting in this direction. 75 degree angle is already given in the figure. F2 is also the force acting. N1 is the contact force, reacting force acting on the contact between the perpendicular to the contact surface. So we find the component of N1, N1 cos 15 degree and N1 sin 15 degree. We also find the components of the force F1, F1 sin 75 degree and F1 cos 75 degree. As 75 degree is here given, if we draw a straight line here, the corresponding angle will be also 75 degree. So in that way, F1 cos 75 degree and F1 sin 75 degree and F2 force given. Free body diagram of block. N2 is the reacting force, 400 Newton is already given. N3 reacting force, F2 the force F2, here also it is acting, here also it is acting, that means F3 is the frictional force, F2, here also the frictional force F2, and F3 is the frictional force, N2 reacting force. Now taking the horizontal components of all the forces, we got to find that N2 minus 0.267 N3 equal to 400. As we already know, tan phi equal to mu, phi equal to tan 15 degree, mu equal to tan 15 degree. We already know the value of phi given 15 degree. So we got the value of mu 0.267. Now we calculate the vertical components of all the forces. Minus F2, vertical components, minus F2 plus N3 minus 1600 equal to 0. From here, minus 0.267 N2 plus N3 equal to 1600. We got to find N2 and N3 with the help of the equation 1 and 2. Now, from the free body diagram of the wedge, which is drawn on the last slide, we can calculate the horizontal components as N1 cos 15 degree minus F1 cos 75 degree minus N2 equal to 0. From here, we calculated N1, 994.08 Newton. And same here also, taking the vertical components, we calculated the value of P, which is 751.478 Newton. Last slide, conclusion. The functionality of a wedge relies on the principle of friction. Wedge problems can be solved using the graphical method, equilibrium method, or Lami's theorem, as they are essentially problems of equilibrium on inclined planes. Wedge friction is a fundamental principle that enables us to perform various tasks efficiently. By understanding how friction interacts with the wedge inclined surfaces, we can optimize the design and use of tools and machines that rely on this principle. Thank you.